Hey guys, let's start with exercise 1.4 real numbers. Let's start with it. Firstly, here you have the first one. Prove that the following are irrational. So guys, in this prove that the following are irrational. So the very first one we have, the first one given over here is 1 by root 2. So we must prove that where 1 by root 2 as an irrational number. As we know 1 by root 2 as an irrational number, right? We know that 1 by root 2 as an irrational number, but we must prove this 1 by root 2 as an irrational number. Okay, so to prove this, what do we do it guys? Firstly, to prove 1 by root 2 as an irrational number, what do we do is, firstly let us assume, okay, what would you do? Let us assume 1 by root 2 is a rational number. Okay, rational number, right? We know rational number, where rational number is in a p by q form. Rational number, clear? Where let us assume, so here where 1 by root 2 is they have to prove 1 by root 2 as an irrational number. So for this, what do we do is, let us assume 1 by root 2 is a rational number. Okay, by assuming this, let us assume 1 by root 2 is a rational number. Then what happens here, where rational number is in the form of, which form is it? Is the rational number in? It is in p by q form, where q is not equal to 0, right? Where a rational number is in the form of p by q form. So therefore I can say where 1 by root 2, we have assumed 1 by root 2 as rational number, right? So thus I am writing 1 by root 2 equal to p by q form. Okay, where p by q, something like an integers, p and q, let p and q be some integer, where obviously we know where q is not equal to 0. Clear? Q is an integer, but where q is not equal to 0. Now what would happen guys here? What we do is now do reciprocal it, like here we will be getting reciprocal. So this becomes what? Root 2 by 1 equal to q by p, right? Q by p. So as you can see, where root 2 by 1 equal to q by p. So where q is not equal to 0, q is some integer, but here we got what? Root 2. So this shows that where root 2 by 1 equal to q by p. Root 2 by 1 equal to q by p, where p and q are rational number, right? We know root 2 as an irrational number, where this contradicts that, where that is root 2 is a rational number, right? This shows, as you can see, this shows root 2 as a rational number, but we know root 2 is an irrational number, because where root 2 is equal to q is a rational number. So therefore this is a contradiction. We got a contradiction where root 2 by 1 cannot be equal to q by p. So therefore we got a contradiction. So therefore this contradicts that. This is a contradiction. Where 1 by root 2 is an irrational number. Clear? Where 1 by root 2 is an irrational number. Clear guys? Hope you got it. Now let me go for the second one, root 3 plus root 5. So prove that root 3 plus root 5 is an irrational number. Wait a minute. So now what they have given, the second question is what? Prove that root 3 plus root 5 is an irrational number. We must prove this. So now what would you do to prove root 3 plus root 5 is an irrational number? Solution. Again, let us consider root 3 plus root 5. Let us consider root 3 plus root 5 as a rational number. Is a rational number. Okay. Let us assume firstly. So guys, here if we cannot prove that root 3 plus root 5 is a rational number, then it definitely would become an irrational number, right? So that's what I am doing. Like let root 3 plus root 5 is a rational number. If I cannot prove root 3 plus root 5 is a rational number, then it definitely would become irrational number, right? So that's what I am assuming this. Okay, let us consider, or okay, let root 3 plus root 5 is a rational number. Now where rational number is in the form of p by q, we know. So then what would we do? Where root 3 plus root 5 equal to p by q. Okay, root 3 plus root 5 equal to p by q. Now at present what we do is squaring on both sides, guys. Let us square on both sides. Like squaring on both sides. Okay, so by doing this thing, by squaring on both sides, like square over here, then what it would happen here, you have root 3 plus root 5. This reminds me of a formula where a plus b whole square, a plus b whole square equal to a plus b whole square equals to a square plus b square plus 2ab. Where should I write? Okay, let it be a square plus b square plus 2ab. Clear? So this is the formula, guys, where a plus b whole square formula, a square plus b square plus 2ab. It's be like 1 year. Okay, let it be. So now here a plus b whole square formula. So now what you do? Apply this formula over here where a plus b whole square formula, a square means root 3 whole square, root 3 whole square plus root 5 whole square plus 2 into root 3 into root 5, which is equal to p square by q square. Clear? P by q whole square. So where this square denotes p square and this square goes for q square. So that's what I have written, like p square by q square. Clear? Clear? Now what would happen over here? We can, like, here you have square, where square root gets cancelled, square root gets cancelled. Where 3 plus 5. 3 plus 5 how much? 8, right? 8. 3 plus 5, 8. Because here square root cancel. We have 3 plus 5. 3 plus 5 gives us what? 8. 8 plus. Here you have root 3 into root 5, guys. Root 3 into root 5. How much? 3 5 is 15. Root 15. So 2 into root 15. Clear? Equals to p square by q square. Can you see the board? Is the board clear? Okay. So 8 plus 2 root 15 equals to p square by q square. Now what you do? So here, let's go for the next step. So somewhere over here, okay? 8 plus root 15. Okay. Now transpose this 8 to the other side, guys. So here you have plus 8, right? Now transpose this 8 to the other side. This becomes what? 2 root 15 equals to p square by q square. So now here you have plus 8. Transposing this becomes minus 8, right? So this becomes what? Minus 8. Now as it is, where root minus 8. So if you take like LCM something like that, then this becomes what? LCM would be q square as it is. LCM into numerator by denominator. Q square into p square by q square. This becomes p square. Is it the one? P square minus LCM into numerator by denominator. This becomes 8q square. 8q square. Clear? Clear till here? Now what happens here? You have root 15 as it is. 2 root 15. 2 root 15. Now transpose this 2 to the other side. So here 2 is getting multiplied. If I transpose this 2, this becomes divided, right? So this becomes where root 15 equal to p square minus 8q square by 2 into. So here it's getting multiplied. If I transpose this, this becomes divided. So here this becomes 2q square. Clear? This becomes what? 2q square. Guys, here where root 15, we know root 15 is a irrational number, right? Where root 15 is an irrational number. So where root 15 equals to p square minus 8q square by 2q square. So here where p and q are also integers, means p and q are also rational numbers, where 8 is also a rational, like 8 is also an integer, where p, q, 2 all are integers, right? They are rational numbers. But here we can see, if you look over here, where root 15 is an irrational number. So where root 15 is not equal to p square minus 8q square by 2q square. We know this, right? We know this. Where p and q are rational numbers, guys. 8 and 2 are integers. So we know where root 15 is not equal to this. Okay, this cannot be equal to this. But this is our contradiction. Okay, we assumed like that. But this cannot be. If we state it, if this cannot, where the process that we done is not correct, means this is the contradiction. Okay, therefore this is a contradiction, or on contradiction, that also we can write. Okay, this contradicts that A and B, where P and Q are integers, where this contradicts that root 3 plus root 5, let it be root 3 plus root 5 is an irrational number. Remember, this is one of the very important questions. You might also get this type of questions in board exams, like make a star mark over here. Okay, these are the many important questions, guys, something like that. Okay, this question might come for 8 marks or 6 mark questions as well as. Now let it be next over, like third one, 6 plus root 2. 6 plus root 2. Let it be. Third question. Okay, 6 plus root 2, guys, where here prove that the following are integers. So here the next question, the third one is prove that where 6 plus root 2 is a rational number. So is an irrational number. Now what would you do? Again go for the previous steps that we have taken, where solution 6 plus root 2. Let 6 plus root 2 is a rational number. Is a rational number, where 6 plus root 2 is a rational number, where rational number means rational number is in the form of P by Q form, where Q is not equal to 0, where 6 plus root 2 is equal to P by Q. 6 plus root 2 equals to what? P by Q, right? Where 6 plus root 2 equal to P by Q. So here where Q is not equal to 0, now what you do, guys, you transpose this 6 plus 6 to the other side, this becomes minus 6, right? Where root 2 equal to P by Q minus 6, where if you go for like LCM, if I take LCM, this becomes what? LCM would be Q. Q will be the LCM, let it be, where LCM is numerator by denominator. LCM is numerator by denominator, this becomes P minus 6Q. Okay, P minus 6Q, where root 2 equal to P minus 6Q by Q. Guys, again we can connect this with the second one, where here we got what? P square minus somewhat like 8Q square by 2Q square, let it be. But here coming back, we have a P and Q are integers. P and Q are rational numbers and P and Q are integers, where 6 is also an integer. But here root 2 is a irrational number, where root 2 is an irrational number, but here P minus 6Q, where this whole here let this be LHS side. Okay, where LHS side is an irrational number, RHS side is a rational number, where irrational number cannot be equal to, where irrational number it cannot be equal to a rational number, right? Where LHS side is irrational number, RHS side is a rational number. So where LHS side means irrational number cannot be a rational number, so therefore this is a contradiction. Therefore this is a contradiction. Therefore this is a contradiction, or this contradicts that 6 plus root 2 is an irrational number. Clear? This contradicts the 6 plus root 2 is an irrational number.